Hello, guys. Good day to you all. My name remains Mr. Victor Shemogi, and I'll be taking you on today's lessons on science. Our topic before us is gravity. So, now what comes to your mind when you hear the word gravity? Here says gravity is a fundamental force of nature that governs the motion of celestial bodies and objects on Earth. It is the force that attracts two bodies towards each other, with its strength depending on the masses and the distance between them. Gravity is the force that pulls everything down towards the Earth, that's towards the center of the Earth. Now, here we're looking at gravity in the solar system. Here we say all planets have gravity. All planets, despite the fact that they're all suspended in the solar system, it still says all the planets have gravity. Like, for instance, the sun's gravity keeps the planets in orbit. You all remember what orbits are. If you follow my videos, you remember we discussed about the solar system. So now we are discussing about gravity. So when we talk about the orbit that keeps all the eight planets revolving, going around the sun. Okay, now bigger objects have stronger gravity, just like the sun and Jupiter. Here we'll be looking at weightlessness. What weightlessness means. Since we've talked about gravity, here is weightlessness. So weightlessness is the feeling or condition that happens when there is no force of gravity acting on your body. Yeah, there's no force of gravity acting on your body. Gravity is like as if you have this weight that once you go up, you are coming down immediately. That's what gravity is. Something is pulling you down to the surface of the earth. Instead of to fall down and go up, you are falling down, going to the ground. That's gravity. Something pulls you down to the surface of this earth. That is gravity. Now, weightlessness is you experiencing that free fall. When you are in free fall and everything around you is falling at the same time, nothing seems to hold back. Nothing is holding you back. You're just there suspending in the air. Like you all know these famous superheroes in the movies. In the movies, movie characters like the what do you call him now? Doctor Strange, yes, and Superman. Those guys, they are just suspended in the air as they like, anytime they like. That is weightlessness. They are not experiencing gravity. They are actually beating the laws of gravity according to the science of their own nature. So let's move on and understand what gravity and weightlessness actually talks about. So here is just a brief comparison between the gravity on Earth and weightlessness in space. Now, gravity on Earth here is the first one says pulls objects down. And in space, weightlessness is experienced. There's no downward pull at all. There's nothing felt as downward pull. If you fall down in space, just as for instance you are running on Earth, the Earth's surface, and you kick a stone, decide then not that you decide that. You fall down, then you fall to the straight to the ground and you sustain injuries. Right there in space, even the astronauts themselves, they can tell you out of their own experience with what I've studied so far that they don't run carelessly, they don't walk carelessly, they don't move around carelessly because they are very careful. In order for them not to trip and begin to float in the air, then float into this world of space without help. Okay, that's why if anything happens to their spaceship, they must and they need to repair it. What they do is this, they strap themselves with a rope into the spaceship, then they come out, the rope is still connected to them and to the spaceship. In case they get to let loose, they can always find their way back through that rope. So what they do is that they come out with the rope and do whatever they are doing in space. They can even float as they like, but for the fact that they are held onto by that rope I mentioned earlier, so that they don't fall and then get lost and missing in space. It's better you get missing here than to go and miss in space. But either ways, don't pray to get missing at all. Now, the second here is we stay on the ground. Yes, we are on the ground. You know, I still make reference to him, Doctor Strange. Sometimes he just sits and crosses legs in the air, just like that. Okay, yeah, that's how it is in space. You can sit in the air, just move around in the air. You don't feel anything like something is pulling you down. Astronauts float in space. Yes, that's the experience of weightlessness. There's a particular height they will get to, and everything will start floating in space. They begin to move freely there. Here we stay on the ground. Then walking is easy on Earth. Walking is very easy, like I mentioned earlier. In space, they walk carefully. They don't walk carelessly. They don't do anything carelessly. They are very cautious of themselves there. Okay, everything floats. Anything that goes up in space does not come down. There's no gravity in space. Everything that goes up there does not come down. It's like a kite flying with the heavy storm. That is how it is over there in space. Despite there's no storm, you are just floating and floating and floating and floating there. Okay. Now, looking at what we have here, gravity on Earth. Earth's gravitational pull causes objects to accelerate at approximately 9.8 meters per second, determining how fast things fall and influencing motion dynamics. Okay, the gravitational forces of the moon and the sun cause ocean tides, affecting marine ecosystems and coastal environments. Gravity keeps Earth atmosphere intact, allowing for life by retaining oxygen, nitrogen, and other essential gases. Okay, here we'll be looking at gravity in space, where we'll talk about weightlessness and orbital motion. Planets and moons stay in stable orbits due to gravitational attraction between them and larger celestial bodies. Now, gravity plays a critical role in star and planet formation by pulling matter together in space. Astronauts in orbit experience microgravity, causing them to float due to the free fall motion around the Earth. Spacecraft require immense energy to escape Earth's gravitational pull and move between celestial bodies.
So over here, we'll be looking at the effects of weightlessness. The first says weightlessness, muscles becomes weaker when they experience weightlessness. Bones loses strength. Astronauts must exercise every day in space. Now, talking of the exercises, the trainings they undergo, if you observe so much, you discover that before traveling out into space, these astronauts and the crew members, they all go into deep waters, like the pools now, deeper pools, to do their exercising because they tend to move slowly, and that is how they move, the way they move in water, that's how they move also in space. Okay, so astronauts must exercise daily, that's every day in space. So everything floats, even water. Everything floats, even water. Unlike here on Earth, when you pour water out of its can or its bottle, you begin to see it drop to the ground, or when you open the tap, it drops to the ground. The water drops to the ground. But over there in space, they don't drop to the ground, they begin to float just in the air, like they float in space, just like the way your kites usually float in the skies. So that is the way water does in space. And muscles and your bones, they begin to lose strength and become so weaker. So your bones are supposed to keep you down to the surface of whatever you're standing on. But in space, it's not like that. Everything begins to lose strength, and so weak that they don't have any force in you to pull you down. Instead, you become like the nylons or the papers that can be taken away with just a little blow of the breeze. Okay.
All right, here is where I call it my rounding up moments of my lessons with you guys. But before I leave, I would love to drop some questions with you. I call it the practice questions to ascertain your level of understanding throughout the process of these lessons. So, the first question I have is, what pulls you down to earth? What actually pulls you down to earth? If you've been following this lesson from the beginning or from the onset, you will understand what actually pulls you down to earth. The second question is this: why do astronauts float in space? Why do you think astronauts float in space? Well, it's you to answer that. Then what happens to your body in space? What really happens to your body in space? So good.
to impute your answers, put them all in the chat box, and then if you have any questions for further clarifications about gravity and weightlessness in space and on Earth, you can just put down your questions in the chat box also, which will be attended to later on. Okay. So guys, we are let's call it a day. This is the end of our lessons on gravity and weightlessness. Like I said earlier, if you have any questions, just place them on the chat box and to be attended to later. So thank you very much for your time. I really do appreciate the time you've spent with us together on these lessons. It's been a successful one already. So see you next in our next lessons. Okay.